All right, everyone, welcome. This is the introduction to the Minikube project. Hopefully everyone's in the right room for that. Today I'm going to be talking about the Minikube project, giving an overview of the technical architecture of Minikube, some of the features it supports, the original design goals. I'll be going over the history of it. Minikube has been around for a few years now. And then we'll get into some advanced kind of tips and features you might not know about if you're a Minikube user to hopefully improve your development environment. And finally, we'll go over some details on how to contribute to Minikube. It's a great way to get involved in the Kubernetes community. This talk is meant to be interactive. Minikube is a tool basically everybody in the Kubernetes community has been familiar with, hopefully. So stop and ask me questions at any point as we go on. And we'll stop at the end too for some more questions. To start off with though, to help me get a feel for the audience, I have a couple of questions. So could you put your hands up if you used Minikube before? A lot of people. Has anybody contributed to Minikube? Awesome. Hopefully we'll get some more contributors out of this talk. At least one person reached out to me before with a PR he wanted to send, so it's going to help him after this. Which operating system are people using Minikube with mostly? OS X? Windows? Linux? A bunch. Cool. So a little bit of background on myself. I'm a TLM of the container tools team at Google in San Francisco. I've been a Minikube maintainer since the start of the project. I worked with some other people to get the project started and have been running it and helping the community ever since. Recently, our team has worked on some other Kubernetes and container features, like Scaffold, rules for building containers with Bazel, some distroless container images, and a whole bunch of other things like that. Little plug, we are hiring, so if this stuff sounds interesting, you can email me after the talk. So the original goal of Minikube was to give people a way to get started with Kubernetes and to have a one command to start up a cluster on your laptop or on a desktop. Before Minikube, there was no real way to do that. You had to set up a cloud provider, enter a credit card, do everything on VM somewhere. Minikube was meant to be a way for people to kick the tires of Kubernetes, start to get familiar with it, and to make it more accessible to people. It was also meant to be used day-to-day by people that are developing applications for Kubernetes. So Minikube provides a lot of ways to streamline your development and to do image builds inside of that. And so it's a lot faster than having to do builds against a remote cluster where you have to upload your source every single build. And the goal is to support most of the Kubernetes features that make sense locally. Obviously, not everything is going to make sense on a little laptop compared to a giant cluster in the cloud. But the goal is to make it as close as possible, so you shouldn't have to change your application source code to run it locally versus in a real cluster somewhere else. Things like multi-node scheduling and affinity don't really make sense in a single node environment, but everything else we try to support. Storage, networking, even some basic auto-scaling. So a history of the project. It was one of the first sub-projects created in the Kubernetes org, and it's been a great experience to be part of the community since the very beginning. We wrote a document as part of the Kubernetes 1.3 release. We're up to 1.10 now. It's kind of crazy to go through that many releases so fast. Around April of 2016, work started immediately. There was a startup at the time, Redspread, that had done a whole bunch of work in this space with a tool called LocalKube, which was a single Go executable that ran every single Kubernetes component that you would need inside the same process as different Go routines. It stood up etcd, the API server, everything like that. So you could just run one command and start everything up. Obviously, it only ran on Linux because Kubernetes only ran on Linux at the time. So we still had to do a little bit more work to make it fully accessible to the rest of the community. After a couple months, we finished up the first couple Minikube releases and launched with Kubernetes 1.3. There was a blog post then, and we got tons of usage and tons of feedback from the community right away. And tons of help from the community as well. There were only a few of us really working on it at the time, but there's something like 300 contributors to Minikube since. And so it's definitely something that couldn't have happened without the scale of the Kubernetes community. Another one of the goals of Minikube was to add support and add ways for people to try out some of the experimental Kubernetes features. So things like Rocket and Cryo have been launched in Minikube first and have been a great way to get these features in the hands of people before the Kubernetes cloud providers really add them. Later on, recently, kubeadmin has come out as an official way to set up a Kubernetes cluster in the cloud. And Minikube has gone through a pretty big re-architecture to use kubeadmin to set up all of the components locally instead of the original local kube binary. So as of now, we've retired local kube and deleted a ton of code that has been around since the start of the project. So it's cool to see almost everything evolve as the community has grown. So the next I'm going to talk about the Minikube architecture, which kind of explains how it works and how it's been designed. There are two main mental models that I've heard a lot of people use to explain Minikube. I kind of like to think of it as a funnel. Minikube is supposed to run a Kubernetes cluster on a laptop, but everybody here probably has a different laptop, a different operating system installed, different tools on it. So that's kind of hard to support. So we try to pack that up inside of a virtual machine that has a consistent environment, so it's easier to set up Kubernetes. This is kind of what the funnel looks like to me. Support OS X, Windows, Linux, and then a whole bunch of drivers to set up virtual machines that are optimized for all these different tools. Different runtimes to set up the containers, and then at the end, the user just deals with a working Kubernetes cluster that they can use with kube control in their terminal. The other model that I hear a lot is that Minikube is like a turducken. If you're not familiar with a turducken, it's a it is a bird that's popular in America, where it's a turkey with a duck and a chicken inside of that. And by that, Minikube has a lot of layers inside of it, so it can be complicated to deal with, but most of these are pretty necessary. What this looks like usually is you have a laptop, and then you start at Minikube, and then it starts up a virtual machine. A couple things run on the virtual machine, like etc and the kubelet, that can't really run inside of containers. But then we start up a container runtime, and then inside of that container runtime, we run containers with the rest of the Kubernetes components in them. We use kubeadmin to do that setup, but so it's actually somewhat self-hosting, where Kubernetes is actually running the Kubernetes components inside of itself. Those are things like the API server, the scheduler, all the other Kubernetes server processes. So actually, if you start up a Minikube cluster locally, I should have one here, and you do a get pods before you've deployed anything, you won't see anything running. But if you do a get pods with the all namespaces flag, you can actually see the Kubernetes server components that are running here in the VM. And so these are all the components that Kubernetes is managing itself, inside of this VM. So if you're not aware of these, you never see them. Any questions so far from anyone in here? Yes. That's a great question. The question was, if I already have to do development inside of a VM, can I use Minikube inside of that VM? Or will I end up with two VMs or something like that? The answer is both are possible. It is possible to run a VM inside of a VM, depending on the host hypervisor. People do that with things like Hyper-V on Windows or KVM on Linux, kind of support nested virtualization. There is also a no VM driver for Minikube, which runs everything directly on the VM. That can be a little bit harder to manage, though, because you need the exact same versions of all of the components that Kubernetes requires. And if you don't have a way to set all of that up, it can be a lot of work for you. Another common case for the no VM driver is to run Minikube inside of like a CI/CD system that's a VM in the cloud somewhere. So as part of a pre-submit check or something like that. Any other questions? Yes. That's correct. Yeah, so Minikube, when you first start it up, it installs the kubelet. It downloads a version of the kubelet that kubeadm uses and installs that on the host. It runs it inside of systemd, a systemd unit, and then it uses kubeadm to bring up the rest of the components inside of containers. Cool. So some of the supported Kubernetes features are things like DNS, so your pods running inside of your VM can use DNS to talk to the other pods running inside of that same VM, which is really helpful when you're trying to transition from a local environment to a distributed environment without having to change anything. The main way to talk to things that are running inside of the VM are using node ports, which is one of the bigger differences between Minikube and running in a full cluster today. The Minikube VM has one IP address for the whole VM, and if you want to address a service, we can't really set up a load balancer on your laptop, so the recommended way is to use node ports. So your service gets a specific port, and then you can talk to that over the Minikube IP address on that port to get routed to that service. Persistent volumes is another recent feature. We have a custom host path provisioner, which sets up directory space inside of that VM. So you can talk to it just like you would talk to a normal persistent volume that's in the cloud, except it's just a directory on that VM locally. Minikube also has ways to map directories from the outside, like the laptop environment, inside the hypervisor. So you can set up a data share from your laptop into the VM and then into a pod through all of the layers of the Turducken. Config maps, secrets work the same. The Kubernetes dashboard is set up by default inside of Minikube, and you can access that with the Minikube dashboard command, which opens up a window in your browser with the Kubernetes UI here. This shows you everything running. You can use it to create new applications. You can enter YAML and everything in here. This shows you the existing namespaces where the Kubernetes system components are running that Minikube sets up. Another less commonly known feature I talked about a little bit earlier is that you can switch out the container runtime used inside of Minikube. Today it supports Docker, Rocket, and Cryo using the CRI spec. So all of these are installed in Minikube. You can only use one of them at a time, so you have to tear down your cluster and start another one up if you want to switch these. But that's something that Signode is working on improving. Minikube also uses the CNI for network interfaces, just like a cloud provider would. And an upcoming feature I'll talk about a little bit later is load balancer support. So we've been working on proposals for a while on how to better fake the load balancer cloud experience to make it so users don't have to change their configurations when running in Minikube versus running inside of a larger cloud cluster. Any questions about these? Awesome. So once you've got your cluster up and you played around with Kubernetes a bit and you're trying to set up Minikube in your day-to-day development for your Kubernetes application. There are some features we've added to Minikube to make that faster and easier for you. Depending on which operating system you're on, mentioned before, you can mount volumes from the host into the virtual machine. You can use this to sync data or sync code. If you have an interpreted language that doesn't require recompilation, you can just sync that code right into your containers. The other cool feature is what really benefits people with slow network connections or very large images is that you can reuse the Docker daemon inside of Minikube. So you can build your images inside of the same Docker daemon that will be used to run them. So you can skip pushing and pulling those images. Without this, you'd have to do a build, push it to a registry somewhere, and then have your cluster or your laptop pull the image back down. This way you can do a build and just run the new container immediately. And depending on your operating system, there's a command like this one to set up those environment variables so that your Docker CLI can talk directly to Minikube. You can also run a whole bunch of custom add-ons that we've built into Minikube. Some of these are enabled by default, like the dashboard I showed, but there are quite a few inside of Minikube that you can play with that have been contributed by the community. So you can see a full list of these with Minikube. Minikube add-ons list, and you can see which ones are enabled by default. The add-on manager itself is an add-on. The storage class is what sets up default host path provisioning. And the Minikube dashboard are all enabled by default. And you can turn on some of these other features like core DNS, ingress is a very common one, Heapster, if you want to experiment with auto-scaling or monitoring your containers. And the other common feature that isn't quite known is that Minikube is heavily configurable, and this configuration can be saved and shared with people across your team. So all of these things like the add-ons you've enabled, special flags for Docker, special flags for the Kubernetes components, can be saved in a Minikube configuration file written yourself in JSON, or you can use it, set these with Minikube config get, Minikube config set. And it'll be persisted across different clusters you set up on your laptop. And you can take that file and share it with your team. so everybody has the same Minikube configuration. Some other power tips. Minikube does ship with bash and shell completion. You can add that to get full completion across all of the Minikube subcommands by running one of these to add it to your bash profile or bash RC. Any questions about this stuff at all? Nothing? Cool. This extra one is pretty powerful and enables you to use the configuration pretty well. You can mount in special folders from your host into the Minikube VM at startup time. So to configure the Docker daemon, in a lot of ways, you need to set up configuration files. They can't be done with flags, and they need to be there when the cluster first starts up. And so there's a special Minikube directory in your home directory that gets copied into the virtual machine mounted from the root directory. So if you need to override a certain file inside of the VM at startup time to configure the API server or the Docker daemon, you can just put that file into your .minikube directory with the right path, and it'll get copied in before any cluster components get started up. Some pretty common ones are to put a script in the boot local directory that'll run to do any further customization. You can download other tools, set those up, even swap out some of the Minikube components this way. Is anyone in the room using this in their Minikube setup? Somebody? No. Another very common feature that's used by a lot of Minikube users is to change out the cluster version. Kubernetes releases new cluster versions, major versions every 3 months, and new minor versions constantly. You typically want Minikube to match the exact version you're running in prod, which you probably don't upgrade that much. It's almost a full-time job to keep upgrading Kubernetes that fast. So you can pin Minikube to a specific Kubernetes version using the --k's version flag. And Minikube supports any of the versions that have been published with kubeadm since about the 1.7 or 1.8 release train. And so before that, it was a bunch of work for the Minikube maintainers to set up new builds for every Kubernetes release that would come out, so Minikube tended to lag behind. But now as soon as a kubeadm build is published, even ones from head, you can switch to those in your cluster. This final one at the bottom is about configuring all of the Kubernetes components dynamically. There's about 1 million switches to all of the different Kubernetes components, like the API server, the proxy, and everything that people need to change. And it would be basically impossible to add flags and configuration for all of that directly to Minikube because they constantly change. So there's a configurator feature in Minikube. It's the --extra config flag. And you can set any flag to any Kubernetes component using this one. So in this example, passing --extra config equals, and we're setting a flag on the kubelet, the foo.bar flag equals baz. And so you can look up the kubeadm configuration for all of your components, and anything that's settable via the kubeadm YAML, you can set with configuration flags to Minikube here. Yeah, and the upcoming features I mentioned before is one of the big projects we're working on now in Minikube is load balancer support. So the community has demoed a whole bunch of different methods for setting this up themselves, and we've kind of taken all of those and combined it into a proposal that we've started working on. So the new load balancer support will assign a dynamic IP address to every single component, every single service in your cluster, instead of having one IP address for everything inside. And it'll use IP tables and route rules on your host to make it so that you can hit those IP addresses directly from your terminal outside the VM, and it'll get routed into the VM correctly. So it'll be just like your laptop is inside of a larger cluster. Things like telepresence have simulated this today before. I want to talk a little bit about contributing to Minikube. It's a great way to get started in the community. Like I mentioned before, we have something like 300 different contributors that have used this as a way to jump into larger Kubernetes projects. A common first PR that people send us is around the add-ons that we support. They're constantly getting updated, and people like to add new ones and update the existing ones. So there's some great documentation on the Kubernetes webpage about how to do that if you haven't sent a PR to a Kubernetes project before. We also always need help with our documentation and examples. We love getting PRs to help fix those. There's no PR that's too small. Cool. So I have a couple demos we could try if people want to ask any specific questions about how to use any of these Minikube features we've talked about, or we can answer questions now. Here in the front. It doesn't show up in the add-ons list. Oh, sorry, is that what you said? We can file a bug and look at it. I'm pretty sure we have it. Over there in the back. Yeah. Yeah, there are definitely some examples. I wasn't aware that Travis had installed Minikube by default, but I've seen a bunch of blog posts and tutorials on how to set that up inside of Travis. A lot of people use the no VM driver for that scenario, and so they have pre-submit tests that deploy configurations and make sure that everything comes up correctly inside of a CI environment. That's definitely something that we use, not for Minikube itself, but for other projects, and it is useful. Is anyone here using that today? Minikube inside of a CI server? Any other questions? Yeah, right there. Great question. Testing Minikube is very difficult because it requires virtual machines, and not all of those support running inside of other virtual machines where tests typically run. We do have a whole bunch of physical machines that are typically under people's desks at work, running things like Windows, and we have a bunch of Mac minis for testing Mac, which is hard to virtualize as well. And so we do a full set of end-to-end tests across all of these different drivers and operating systems on physical machines. It's hard to keep them passing all the time because these machines need to be rebooted and logged into to keep them up. But yeah, we do try very hard to test Minikube across all of these platforms. I think we're the only Kubernetes project that has tests on Mac OS X today because it's so difficult to do. Yes? So the question was regarding the difference between the configuration file and flags for configuring Minikube. Not all flags are supported in the configuration file. Yeah, our goal is to try to support all of them in the configuration file, but the configuration file is JSON, and some of these flags have very strange and difficult types to marshal into JSON. So we typically have to special case flags that people need that we can't just turn into JSON directly. If there's a specific one you're interested in, we can add support for that. Do you have an example? The networking plugin. I'm not sure of the details on that one, but yeah, it should be fixable. In the back? The question was, do we know what the Minikube users are using it for? Is it local development or CI? Was it used before Git push or after? I think the answer is both. People use it for all sorts of things. There was just a very large community survey done by SIG Apps where we added a whole bunch of Minikube questions and got some of the best feedback we've gotten so far on how users are using it. I think that was one of the questions. The results just came out last night at the SIG Apps deep dive. So they're available to everyone, so you can take a look at those if you're interested. Nobody in this room raised their hands about CI systems. So, yes. So the question was if I could outline some better ways to use Minikube in CI because it's nice as a reproducible environment. The best practices I've seen are typically the ones documented in the Travis CI blog about how to do it. The very first thing that happens is a fixed version of Minikube is installed. Minikube does new releases, and as new Kubernetes releases come out, we switch the default version. So one common pitfall I see is that people use the latest version of Minikube, and then one day the Kubernetes version will change, and some of their things will break. So you should pin to a specific version of Minikube, and that holds true for anything you're installing in a CI system. Make sure you know exactly what version you have. And then start everything up, do your tests, and then tear it all down at the end and start fresh. Is the easiest way to make sure everything is reproducible every time. Did you have any other specific questions about that? Or? So the specific example is when you have to spin up a whole bunch of dependencies, like things like RabbitMQ alongside your application. Yeah, I haven't seen any great tools around that. I've seen a whole bunch of very similar shell scripts that I've written many times to start something and then keep pulling kubectl to wait for the services to start. I think that would be a great project, and the community would really appreciate a tool that let you declaratively specify these things, waited for them all to come up, and then run a set of integration tests for your app. I just haven't seen one today. If anybody else is aware of one, definitely let the community know. Right here.
You said when you used the no VM driver, and then you said there were some additional steps to make that work. Could you delve into that some?
Yeah, so the question was, if you use the no VM driver, are there any extra steps you have to follow? And yeah, basically the no VM driver works by running Kubernetes on whatever VM or physical machine you're trying to use it on. And so you have to make sure that all of the Kubernetes dependencies are present. Kubernetes isn't fully self-contained. It depends on a whole bunch of special versions of Linux tools that are installed on the VM itself. That's basically it. So you have to make sure you have the correct versions of things like ethtool and IP tables and SOCAT and things like that that the proxy and the other Kubernetes components will use. Which is why it's so much easier for Minikube to test itself inside of a VM where we can control the versions of everything. But if you're doing it yourself on your own machine, then it's up to you, basically.
Is the tool available somewhere? I haven't checked.
Some documentation may be out of date, always a warning. But yeah, the Kubernetes team tries to document the exact versions of everything required with each Kubernetes release. So you have to pay attention because those change over time. In the back. So the question was, is there a way to fake resources inside of Minikube so you can pretend your laptop has 4 CPUs if it only has 2? For that specific example, I'm not sure if it would be possible. Minikube does support flags to configure the CPUs and RAM that are available inside of the cluster, but I think pretty sure you can only configure those to be things that are less than what your machine actually has. So I think the default is 4 CPUs and 4 gigabytes of RAM or something like that. So it doesn't completely shut down anything else you're running on your laptop. But if you have a beefy machine, you can turn those up to whatever your laptop has available. Anything else? All right, thanks everybody for coming. I hope we